right, so I added on to that warm-up just like a quick review of all the properties that you should know up to this point. So the properties of quadrilaterals is really only one thing, like that big box. What's true about a quadrilateral? It has 4 sides, right? What other thing do we know about it? What's true about all the angles inside a quadrilateral?
Equal 360.
360. So those are like the 2 properties that you can add that are just general properties of a quadrilateral. Any quadrilateral? So 4 sides, you logged out. And angles sum to 360. Those are the 2 things you know about every quadrilateral, okay? Then within there we've got parallelograms, and parallelograms have opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisect each other, and this is Evans. He wrote same side angles, which same as consecutive angles, are supplementary, okay? Then you've got the properties of the rhombuses, which is all sides are congruent and the diagonals are perpendicular. There's also one more property to rhombuses. What is it? Emily. Good. The diagonals bisect the opposite angles. And then the properties of the rectangles, all the angles are congruent. They all equal 90 degrees to be even more specific. What else is true about a rectangle? Claudia, you had it. Good. Diagonals are congruent. And then the properties of squares is everything, right? I kind of try to make it visual. So you've got your blue and your pink. When you overlap blue and red, what happens? You get purple. Jeez. When you combine blue and red, this is also a lesson in primary colors. When you combine blue and red, you get purple, okay? So when I combine the properties of a rhombus with a rectangle, you get all the properties of the 2 combined, okay? So everything on this slide needs to be ingrained in your brain from here on out, okay? Because we're going to build on it. All right, so the first questions here said to name each type of quadrilateral for which the statement is true. Both pairs of opposite angles, and that should be angles, not angels, are congruent, and it would be all 4 of them. If it's a property of a parallelogram, then it's going to trickle all the way down. Parallelogram, rectangle, rhombus, and square. And then the second one is the quadrilateral is equilateral, and equilateral means what? All the sides are congruent. So this is going to be true for a rhombus and for a square. Emily's, good job, Emily. Emily Jariga, that was hers. Okay, this is Alejandro. So given the rhombus MNOP, find angle NPO. And so some of you struggled on this one, so let's go over it, okay? So if it's asking for angle NPO, which is this angle here, what was given to you is this 48. So ignore these, because we don't need them yet, okay? What we do know about a rhombus is that the angles are bisected, which means if this is 48, then this is also 48. It's still a parallelogram, so the alternate interior angles are still congruent and opposite angles are congruent and bisected, which means that both of those other parts would be 48, okay? The other angles, should it have asked for these, I would have done 180 minus the sum of these 2. So 48 plus 48, which is 96, subtracted it from 180, and I would have gotten 84. That's the whole angle here. And then I could have divided it by 2 and gotten 42 for each of these. So some of you gave that 42. Be careful, okay? So the NPO should have just been 48 degrees. Opposite angles are congruent and bisected. Okay, and then the last one, another, again, a little, some of you guys got hung up on this one. So if it says, given a rectangle, which means the angles are, God bless you, are 90 degrees. So this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. If they gave you 64 here, I would have subtracted it from 90 to get this little missing sliver here, which is 26. Same thing happens on this side. This is also 26. Think about the fact that the diagonals bisect each other and are congruent. So this is like an isosceles triangle on the bottom. Whatever angle is on the bottom left is also going to be on the bottom right. And then if I do 26 plus 26, I get 52. Subtract that from 180, and I get 128, which is this angle here at the top. So all of the properties of triangles still apply. So an isosceles triangle, each of those triangles formed by the diagonals in a rectangle are going to be isosceles triangles. Questions overall on the warm-up? So obviously the first step is in knowing the properties, but then you've got to figure out how to apply them. All right, so if you'll open the notes, we're going to do that first, and then we'll go back to the homework. So we're learning two new quadrilaterals. The first is a trapezoid, and the second is a kite, okay? Neither of these are parallelograms. So if I'm going to split up my box as in quadrilaterals, I would now have to put this into two boxes, one in which is the parallelograms, which would be the rectangles, the rhombuses, and the squares, and then separate from that would be trapezoids and kites. So they are not parallelograms, meaning they don't carry over all the same properties that we just talked about. The only thing they have in common with the other two is that they're four-sided and sum to 50 degrees. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So you cannot have both pairs. One pair of parallel sides. Each of the parallel sides is called a base. So the two sides that are parallel are called the base. The non-parallel sides are called the legs. The base angles of a trapezoid are two consecutive angles whose common side is the base. So if I draw my two bases, the two parallel sides are the bases, the non-parallel sides are the legs. Where the leg meets the base, these are called base angles. So in each of my four, and they come in pairs, okay? So B and C are a pair of base angles, and A and D are a pair of base angles. An isosceles trapezoid is a trapezoid in which the legs are congruent.
Are these called leg angles?
No, they don't have. They're both called base angles. They're just in pairs. An isosceles trapezoid is where the legs are congruent. So the parallel sides can't be congruent. Can anybody tell me why?
Because the trapezoid is section.
What would happen if I had one pair of sides that's parallel and congruent? It's a parallelogram. Is a trapezoid a parallelogram? No. So the parallel sides can never be congruent. Does that make sense? Okay. But if the legs are congruent, then it's called an isosceles trapezoid. And there are things we know about isosceles trapezoids. The first is that each pair of base angles is congruent. So in the drawing that's there, angle B would be congruent to angle C, and angle A would be congruent to angle D. The opposite ones can't be congruent because then it would be a parallelogram, okay? But the base angles are congruent in an isosceles trapezoid. So if these two legs are congruent, then the base angles are congruent. The second is if a trapezoid has a pair of congruent base angles, then it's an isosceles triangle. Isosceles trapezoid. So flip that statement to the converse to it. Now I would say if one pair of base angles is congruent, then I know that this quadrilateral is a trapezoid. That is isosceles. And then the last one, a trapezoid is isosceles if and only if its diagonals are congruent. So if AC equals BD, then this is an isosceles trapezoid. And if it's an isosceles trapezoid, then AC equals BD. Okay, the mid-segment of a trapezoid. So we have had a mid-segment of a triangle. Okay, this is similar but not the exact same thing. The mid-segment of the trapezoid is the segment whose endpoints are the midpoints of the legs. So this here would be the midpoint of the left side, and this here would be the midpoint of the right side. And that's called the mid-segment. So it will either say that points A and B are the midpoints of the sides, or you'll see these little tick marks like you've got. This is also showing that that's the midpoint. Okay, theorem about the midsegment. So this is midsegment's theorem for trapezoids, which says that the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So this is where it becomes different from a triangle. The triangle midsegment, we said the same thing initially. We said that it would be parallel to the third side, but we said it was 1/2 the length of the third side. With a trapezoid, it's 1/2 the length of the sum of the bases. So 1/2 base 1 plus base 2. So XY in this case is my midsegment. It's parallel to both BC and AD, and it's equal to 1/2 the length of BC plus AD. Okay, second shape, second quadrilateral, is a kite. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So the sides one after the other, or the 2 sides that meet, would be congruent. So in this case, AB would be congruent to AD, and BC is congruent to DC. 2 pairs of congruent sides, but they are consecutive, not opposite each other. Again, if there was 2 pairs of opposite sides congruent, what is it? A parallelogram, and a kite is not a parallelogram. Okay. Think about the shape of an actual kite. Like if I do this, okay, it looks like an actual kite that you used to fly in the air. Okay, properties of kites. So if a quadrilateral is a kite, then its diagonals are perpendicular. What other shape has perpendicular diagonals?
Rhombus.
A rhombus and a? Nope. And a square. If it's true about a rhombus, it's true about a square, right?
The rectangles are...
Rectangle, they're congruent. The diagonals are congruent. So isosceles trapezoid and a rectangle and a square have congruent diagonals. All right, and then the second thing about a kite is if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Only 1 pair. So exactly means only 1, not both. And it's the pair where the 2 non-congruent sides meet. So in the kite that's there, angle B would be congruent to angle D, not angle C and angle A. So the 2 angles where the non-congruent sides meet each other, those are the ones that would be congruent. So now we get to apply it all. So again, it comes with more properties. You want to, again, if you're making an outline, you want to add to, okay? I think I have a Quizlet. I have to post it. But it has most of these properties as well. So this one, first thing you have to do is identify what kind of shape this is, which is what? A trapezoid. Specifically, an isosceles trapezoid. So what's true about the angles in an isosceles trapezoid? They add up to 360. In an isosceles, when the base angles are congruent, right? This one would equal this one. This one would equal this one. Same side are still parallel, so same side interior would still be supplementary. So if I know that this is 100 and this is 100, and all 4 of them add up to 360, I end up with 130 for the sum of the other 2. Or that's 160, just kidding. 160 is the sum of the other 2, which makes each one what? 80 degrees. Questions on that one? Okay, now it says find angle F. I'll give you a second to work on it. Okay, so what shape is this again? Isosceles trapezoid. Base angles would be congruent. So angle H is going to be congruent to angle E. Those would both be 49 degrees. The sum of those would be what? 98. So I could either add them, subtract it from 360. This time it might even be faster to just say these are same side interior and these are same side interior. So how else could I have gotten angle F? 180 minus 49, which is what?
Interruption. The JV.
All right, so now we're dealing with the length inside an isosceles trapezoid. What do I know about, so KB is part of the diagonal. What about, I know about the diagonals in an isosceles trapezoid? They're congruent, so KJ is going to equal FM, and it gives me KB is 21.9, and MF, which is this big length here, is 32.7. So if I want to find FB, there's two things I could do. What's the first? Good, 32.7 minus, oops, what did I say? Minus 21.9. And I get 10.8. So that's going to be this length, which also means this length. Okay, again, think about these are isosceles triangles, right? So the other way I could have looked at it is that if these are, if the base angles are congruent, then these two are congruent. That 21.9 would go to both sides. Subtract, either way, you have to subtract it from 32.7. And I get 10.8. Questions on that one? Okay, now we're talking about kites. So in kite ABCD, angle DAB is 54. So this angle here is 54. And CDF is 52. CDF, which is here, is 52. Okay, so they're asking for BCD, which is this angle here. Okay, so now I know what about the angles? Same thing we just talked about, right? If it's a kite, these are still congruent. This is still an isosceles triangle. This is still 52 degrees, right? I still don't need that 54. And then that triangle would add up to what? 180, so 52 plus 52, 104, subtract it from 180, and I get 76 degrees. I could have gone the other way, so I could have used the 54 on this side, right, because that's also an isosceles triangle. I could have found these angles, and then known the opposite angles are congruent, added those together, subtracted it from 360, because I know all four angles have to add up to 360. But obviously the first way is a little bit faster. Questions on that one? Oh. All right. Now it says, Lucy is framing a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters, 1 dowel that measures 30 centimeters, and 2 dowels that measure 27 centimeters. To complete the kite, she needs a dowel to place along KL. She has a dowel that's 36 centimeters long. How much wood would she have left after cutting the last dowel? So they labeled it out for you. You've got 18 and 18 on the two sides, 27 and 27 on the other two sides. And I know straight across here is 30. So she needs to complete the kite, which means she needs that KL, correct? How could I find it? Good. What do you know about the diagonals? Well, before you even know that, because yes, that's true, but what else? They're perpendicular, right? So they're perpendicular, which means I have 4 right triangles here, okay? So this would be 15, this would be 15. And then do you remember the triple? It's blank, 15, 18. Just kidding. How would you find it? It's 8, 15, 17. That's not this one. How do I find the missing side? A squared plus B squared equals
Oh my God.
C squared. Hasn't been that long. 15 times 15. 225. 18 times 18. Oh my gosh, I have to multiply numbers together. No. Pythagorean theorem is one of those things that never goes away. Never, 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 never.
Everything is so confusing now. You just square just a second.
No, there's always been triangles involved. So this would be 9 and 11, which is 3 root 11. Now they're asking me like how much is left, so obviously I've got to estimate this. I'm not going to subtract when I'm dealing with square root. So what is the square root of 11 close to? Or what's the square root? You can go 99 too, but square root 11 is in between 9 and 16, right? Is it closer to 9 or closer to 16? 9, which means if I square rooted this, it would be like 3. This would be 4. Let's say that this is approximately 3 times 3.2. It's just approximate. So that's how much I would need for this side, right? Which we just said was what? I didn't write it down. 9.6. Now I've got to complete this one. It's also a right triangle though, right? So I'd get 15 squared plus x squared equals 27 squared. We already did 15, 225. 27 times 27. And then subtract the 225. Which would be 252, 126. Oh, this could keep going. But I actually just need the approximation, so I could approximate it from here. This would be 2 square root 126. What is the square root of 126 closest to? Perfect square wise. It's in between 11 and 12, right? 11 squared is what? 121. So it's pretty close to 11 squared. Let's say that this is 11.2. Multiply that times the 2, 22.4. So 22.4. So I've approximated one length to be 22.4, the other at 9.6, which means it's approximately 30 that I need to complete that side. How much would she have left is the question. Approximately 6 centimeters. So this is a really good, think about it as an SAT question. On an SAT, you would have a scientific calculator, which would have made that a little bit easier. Okay, I wanted to show you can do it without, but obviously if it's something like that, you would. Evan. Oh, yeah, this would be 32. And then it would be 36 minus 32, which is 4. Okay, my brain's working just about as hard as your guys' is. Questions? So again, I would say that's a better SAT question. You're probably not going to see something like on your test, but if you do get something like it, obviously it's a good application of the properties you just learned in with triangles and Pythagorean theorem, which all that stuff's not going to go away. So you want to make sure it's a good review every once in a while to go back through it.